Hello and welcome to part 6, the final video in this video series of Qnect learning modules. In this video, we're going to focus on beam to column connections. These connections can either be beam to column flange connections, as shown here where the connection is to the flange of the column, or beam to column web connections, as shown here where the connection is to the web of the column. Let's first go into our dashboard and update the parameters for our job. So we want to sign in to Qnect.com, go to your dashboard and edit whatever job you're using for this project. Right? We want to go into connection types and we want to modify the settings of preferences for different kinds of connections so that we can more quickly switch between different connections. So we're going to look at beam to column flange connections, and currently it's set for shear plate connection. I want to switch that to a double angle knifed connection, bolted at the beam and welded at the column flange. Then I'm going to change it to bolted configuration, bolted at the beam and bolted at the column flange, and then I'll put the shear plate connection last. You can add a fourth one if you'd like, as just an additional parameter that you can change later on your own. When we look at the beam to column web, extended shear plate is our initial option that's here. If I try to add double angles to it, it will give me an error, because these are those two-way connections where we have a connection framing in on either side of the web, and we can't be mixing methods. So we either need to make them all extended shear plate or all double angle. So I'm going to make them double angle, and I'm going to select bolted, and then we can do the bolted welded option as well. If you want to look at the extended shear plate, you'd have to go back in later and change it to extended shear plate. Right? And then we want to make sure that we submit it so that it's saved. Right? Now I'm going to go into the connection within Tekla, and I'm going to look at column C2, the column at the lowest level. So I'm going to look at what is going on with the framing into this specific column here. For the sake of just making things a little bit easier to see, I'm going to go ahead and select things around that region, just trying to select the beam and the columns that pertain to what we're trying to look at here. And if you right click while holding shift, hold down shift and click show only selected, it will give you just the members that you want. And it seems that I over selected. So all you have to do is you go back to view, redraw all views. That puts everything back. And I want to make sure that I add in this connection here as well. So now I hold down shift, right click, show only selected, and now we have just what we're looking at with this column. All right. So let's first look at the beam to column flange connection. This connection right now is showing a simple shear plate or shear tab connection. The beam to column flange connections aren't really too different than beam to girder connections that we've already covered, but you'll notice that there are a few things we need to take into account. So there isn't a top cope on the beam. The top cope was needed in the beam to girder connection because of the girder flanges. Here there aren't any conflicts in the beams, would easily be able to lower it into place without needing a cope. When using a double angle or an end plate connection, we are limited by the width of the column flange. This is our connection surface, and we can't extend beyond that. So we need to make sure that whatever is needed with regards to the angle connection, the bolts and the weld, that they have enough edge distance to be able to be a suitable connection. When we had the girder as a support, the girder had a long length, and we really didn't run into this issue of having a limited width to our support. So let's see what happens if we switch this to a double angle connection. If you already had one in place, go ahead and click on the connection and delete it. And then we are going to export the information. So if I look quickly, just give you the information about this connection here. It is a W24 by 62. And if I look at the parameters in terms of what it needs to be designed for, I can look at the user attributes and I can see that it's designed for 72 kips of load at this end. Okay, so it's a pretty large member. Now what we're going to do is go ahead and figure out the design for this connection. So I'm going to select this beam and this column, and I'm going to go to Qnect button and I'm going to export it. And it will create for me my preferred connection, which was the double angle connection. So I'm going to call this C2. Any kind of name that you haven't used before would be fine, as long as you can identify it. I'm going to call it C21 for column 2 location, the first connection we're running. So you'll get an email when it works or if it doesn't work. But if you go to import, if it pops up, it means that it's been successful. So you can go ahead and submit it. Okay, so our first option was the knifed connection. That meant that we had double angles that come out welded to the column, and then the beam would be lowered in place and then bolted using, in this case, 4 bolts. So what you'll see is at the bottom here, there is a bottom cope to the connection. That's because if you think about there being 2 angles there, you have very little space to work with to be able to fit that member in. By coping the bottom, what they're able to do is thread it down in between or knife it in between, which is why it's called a knife connection, and then bolt it into place. You'll see here that the angles that were used fit nicely within the column flange width, and there's enough space for the welding to be performed. So let's go ahead and switch this connection out. I'm going to adjust the user attributes. It's pink here, which shows that pink end condition, and I'm going to adjust this to be a bolted connection. It says bolted at girder, but it should still perform just fine. We want to modify it, we want to apply it, and then click OK. Now when we connect the column and the beam, we go ahead and export it. I'm going to call this C21B for bolting it. Going to submit it. Then I'm going to import it. It popped up, so it successfully ran the job. And now you can see the results of a bolted connection. One of the things to look out for if bolting to the column flange is to make sure you're using a gauge or a horizontal center-to-center bolt spacing that will work for your column. And Qnect will do this automatically, but if you're designing it on your own, you'd want to look for that. This column here is showing what a gauge is, so it's that horizontal spacing between the bolts. The steel manual will give you a workable gauge that's recommended, and I'll show you where you can find that in a moment. The workable gauge comes from past recommendations from fabricators. It satisfies minimum edge distances, so the spacing from the center of the bolt to the edge of the column, and necessary spacing requirements for the bolts. It also provides spacing for entering or tightening clearances and avoids the chamfer of the column web. In the old days, punching or drilling of the holes would be tedious if the gauge size wasn't standardized, and the need to adjust the gauge distance in the punching or drilling line really slowed things down. Today, it's not as much of an issue, but still using a standard gauge for each shape may save the designer money. But other gauges can be used if they satisfy the edge distances, spacing, and entering or tightening clearances. This is the standard gauge for this shape, but consideration of a different spacing may be needed if there is a skewed connection or some other reason that it would be difficult to tighten the bolts. So in this case, you can see there is a skewed connection here, and being able to tighten this set of bolts would be challenging, so moving it outward could help fix that problem. Table 1-1 of the manual gives workable gauges for wide flange shapes. You can see for the W14x90, it's 5.5 inches. There are also gauges provided for T's as well as for angles as shown here. If we go back to the Tekla model, you'll see that bolts may be staggered as shown in this connection. There's a vertical offset between the bolts in the column versus the bolts in the beam. This is often done for entering or tightening clearances. The shop installed bolts that are on the beam may interfere with the field installed bolts connected to the column. This is especially an issue with tension controlled or TC bolts that have longer ends that need to be sheared off. Beam to column web connections have a number of difficulties due to lack of space to work with between the column flanges. If you have a conventional shear tab, meaning that it only extends the bolts out a few inches from the face of the column web, you likely would have a hard time trying to get an impact wrench in there between the column flanges in order to tighten the bolts. Thus, bolting directly to the web by some means, or extending out the connection so that you can bolt transversely from the beam in an area where it's not conflicting with the column, such as what's shown here, these are really preferable methods of connecting. So let's see what a double angle connection would look like. I'm going to go ahead and delete this connection. And I will delete it on both sides. Once you delete something, everything shows up again. I'm going to zoom out, make my way around, delete the other side here. And I'm going to delete those. All right, so we had a setting already set for double angle connections. So I'm going to select the beams and the columns, and I'm going to export their information so that they can be designed. I'm going to call this beam column web, and I'm going to call it 1. Now I'm going to import that design. And I'm going to go ahead and try to just select the pertinent stuff so that I can kind of get rid of everything else here. So for now, I'm going to right click, hold down Shift, show only selected, and that's probably good enough for us for now. All right, so let's take a look at the connection that was designed. So if we scroll our way around here, let me go on this side. You all might be better at navigating this than I. But let's take a look. So we have a bolted to the column web and welded to the beam connection. So the angle will come out on the beam and then it will be installed and bolted into the column web. Now, you can see that there's an offset here where we have a bolt down here that doesn't have an angle. Well, if you look at the opposite side, what you'll see is that the angles have been staggered. So here we have an angle up higher and it's using the top 3 bolts. On the other side of the connection, it'd be using the second, third, and fourth bolts. What this does, it allows for that issue of erection. So we can still connect both, and you could use in this example the top set of bolts on either side as your 2 erection bolts. On the other side, you can use the lower ones that wouldn't conflict with this connection, and then you don't need to have any kind of erection seat. If you didn't do this offset, you could provide basically a seated angle, a temporary erection seat, or you'd have to have some other means of ensuring that you're going to have stability while you install the connection on the opposite side. So in this example, the column web, or the spacing between the column flanges, is large enough that the beam can fit in there in between the column flanges. There's room for that. There's also room for the angle legs. If you get into column sizes that aren't very deep, you might run into issues doing these double angle connections because you might not be able to get an angle with enough room to be able to fit in there. If your angles can fit, but your beam flange is too wide to fit within the column, what you can do is notch out portions of your flange just as needed to clear the columns so that you can get that beam in there close to the double angles. Another option is to use an extended shear plate connection. So for that, I'm going to go ahead and delete this connection. And because we were told it to use double angle connections before, we're going to have to go back into here and we're going to have to adjust our settings. Now we will select submit. And now when we run this connection, and we'll run the column and the beam on the opposite side, when we run this connection, we'll see a shear tab, extended shear tab connection. I'm going to call it ST1 for shear tab. When we submit it, what we see is back to that extended shear tab connection that we saw initially. So this line of bolts is extended out beyond the column's flanges. So it allows you to connect in there with an impact wrench. However, it does create a large eccentricity that needs to be considered in design. Oftentimes, this large eccentricity may require multiple bolts, which is what we're seeing here, 2 lines of bolts. And this is extra that's needed because of the large eccentricity that's created on the bolt group. If it was a more conventional shear tab connection, you might not need as many bolts because you wouldn't have as much eccentricity to account for. Of course, you can double click on the connections, look through the information, do a comparison of, look at the cost information, as well as connection information. So here you can look through all the calculations for the connection, look at the capacity of it, and all of that. All right, at this point, you now hopefully are able to navigate Qnect and Tekla with relative ease. I hope you've enjoyed these modules and that you'll take some time to explore the many options provided by Qnect. Happy designing!